For the next few lessons, we're going to talk about something called points of concurrency. And there's a few points that we're going to talk about in particular. The first one we're going to talk about today is called the circumcenter. Before we get into that, let me have you grab one of the warm-ups and pause the video and just try working on this page. Fill out the midpoint table and then write the equation of the perpendicular line. Okay, so hopefully you paused the video and you did all that, and now you're hitting play, or you already did it in class, remembering that a midpoint should be an XY value in the middle. It's a point in the very middle between these two, and we're doing it in a proof just to justify our reasonings. And then we write the equation of the perpendicular line. You use the opposite reciprocal slope, and you make sure that it goes through these points by using either point slope form or slope-intercept form. And then when you graph them both, you realize that perpendicular means that they intersect at 90 degrees. So that was just a little review. If you can get out your notes, we are on section 4.4, Circumcenter. That's a new vocabulary word. All these other ones you've heard before, but this one should be new to you. And for this lesson, we'll need to remember to use the midpoint formula and slope-intercept form, and maybe even the distance formula and the Pythagorean theorem. So those are some old formulas we need to be successful. We talked about intro to triangles already. That's classifying triangles, proving it's a triangle, and then once you prove it is a triangle, then you can classify it by sides and angles. And if you don't have the angles, you can use this converse of the Pythagorean theorem in order to classify it by angles just using the sides. Then we talked about interior angles, something you've learned before, but I added in putting it in a proof, and then I added in some algebra. And then last lesson we talked about this concept of an exterior angle, and back in the day you probably solved all the interior angles and then realized you had a straight line that adds up to 180. Remember, the shortcut is the exterior angle equals the two remote interior angles, the two angles it's not touching, added together. Remember this concept of isosceles triangles, recognizing if you have two sides that are the same, you have two base angles that are the same. And those base angles don't mean they're on the bottom. They're on the congruent sides where they don't meet up. If you have all the exterior angles, they add up to 360. So now for our lesson today, we're going to talk about circumcenter off the graph and on the graph. So if you can grab your notes, and let's go to the top left. Let's talk about off the graph first. So, well, actually, even before that, let's talk about what a point of concurrency is. A point of concurrency is an intersection of three or more lines. So if I have two lines that intersect, we just call that an intersection. But if we're lucky enough to have three that intersect at the same point, that is called a point of concurrency. And man, I can't draw apparently. So I have these three lines. I know they're really bold, but let's act like they weren't. They're going to intersect all at one point. And the most special point of concurrency we're going to talk about today is called the circumcenter. And the circumcenter is the point of concurrency of the perpendicular bisectors. So imagine I had these three lines, and they are all perpendicular bisectors of a triangle, where they're all going to magically meet up at the same point, and that's called the circumcenter. The application for a circumcenter is that it is equidistant or equally distant to the angles or to the vertices, to those corner points. So how do we draw a circumcenter? Well, we got to draw these perpendicular bisectors. And the way to draw perpendicular bisectors is, well, let me scoot this up. We're going to focus on how to do it off the graph first, and then we'll do this on the graph. How to create perpendicular bisectors. You're first going to bisect the side of the triangle, each side of the triangle. And the way you do that is you grab a ruler and you measure the length of the side. Let's say it's 5 centimeters long. Divide that by 2. You're going to put a dot halfway in between. So at half of 5 would be 2.5. So I put a little dot at 2.5 centimeters. And you're going to do that to every side. Then you're going to draw a perpendicular line. That means a 90-degree angle. The way I do that, you can use a protractor, but the way I do that is I get a piece of paper and I hold up the corner of the piece of paper to my midpoint to my bisected point, and I can draw a straight line that way. I'll demonstrate that in class. So here I have a triangle. I have an acute triangle, a right triangle, and an obtuse triangle. And the first thing I'll do, measure the side and find the midpoint and put a little dot on every single midpoint. So I know that my dots are really, really big. Sorry, it's my animation. They really shouldn't be that big. They should be like a little dot. And then draw a perpendicular line. So get a note card or get a sticky note or another piece of paper and hold it up to the side of the triangle that you bisected. And when you hold it up flush with the side, you can just trace the edge of that paper or that sticky note or that note card, and that'll be a perpendicular line. And then do that to another side, and then another side, and they're all going to meet up out a single point, and that's called the circumcenter. And the reason it's called the circumcenter is because I can draw a circle. Well, maybe I can draw a circle. I can draw a circle, and imagine that was a circle. I'm drawing this by hand. And as I draw this circle, the vertices, the angles of my circle, are all going to be on the circle. So the circumcenter is the center of a magical circle. And so remember, that's a radius, that's a radius, that's a radius. Those radii, they're all equidistant. So the circumcenter is equally far from the angles. Same thing on the right triangle. On my midpoint, if I draw my perpendicular lines, they're all going to meet up right here on the edge of the circle. And if I wanted to draw a circle around this, imagine I can draw a circle. All of my angles of my triangle are going to be on the edge of the circle, and then from the circumcenter, all those lengths are the same. Now for the obtuse triangle, this one might have been the trickiest one. Draw your 90-degree angles, and they're actually going to meet on the outside of the triangle. So again, if I draw my circle, this one's a little bit, oh, I'm doing really bad on this one. Let me see if I can't undo that one. Oh, I don't know, I couldn't figure it out. Oof, that's a really bad circle. I probably should have done an animation on this. Well, anyway, the vertices of my circle, they're all equidistant, equally far from the center of my circle. That's why it's called the circumcenter. So if it is in fact equally distant to the angles, we can use it in real life. So here's a made-up situation I had. My husband, Mr. Roberts, if he claims that Keller is equally far from the 3 airports on the map. Is that true? Well, here's an airport, here's an airport, here's an airport. If I connect them, I magically have a triangle. Use a straight edge when you do this on your paper. Now you can tell this is clearly closer to this top left airport, not equally distant to these airports. But you don't just tell someone you're wrong, you got to tell them what the real answer is. So we're going to find the circumcenter, because that is the point that is equally far from angles of a triangle. You measure a side and you bisect it, you measure a side and you bisect it, you measure a side and you bisect it, and then you draw a perpendicular line. So I'll get my straight edge, or my corner, draw a 90-degree angle here, 90-degree angle here, and a 90-degree angle here. They're all going to match up. So I wouldn't just say, hey, you're wrong. I would say, hey, no, Keller is not equally far from the angles. Whatever this location is, that's equally far from the 3 airports on this graph. Okay. So to apply the circumcenter, we don't have to be on a graph. We can do some basic math with it, because we remember that if I connect my angles to the circumcenter, these segments are going to be congruent because they're equidistant. Even if there aren't any segments, I'm going to draw the segments and they're going to be congruent. So here's an example. I'm just going to kind of estimate. That's the midpoint. That would be the midpoint. So my circumcenter is like around here. So M is the midpoint of the side. C is the circumcenter of the triangle. If UM is 5, so from here to here, if that's 5, what is ME? Well, remember, M is the midpoint, so UM must be half the side, so the other half must be 5. The whole length from U to E better be 10. Okay? If CT, let me draw that. If CT, well, that wasn't really good. If CT is 7, what is CE? Well, remember, this is the circumcenter, so I could draw a circle. Not very well, though, apparently. I could draw a circle, and all my vertices would be on that circle. So that means that this radius is congruent to this radius. So if CT is 7, CE is 7. And so is CU if you really wanted to know. Okay. If UM is 5 and CT is 7, what is CM? Well, remember, if CT is 7, CU is 7. And then to create the circumcenter, we had to draw perpendicular bisectors. So if I have a right triangle, how do you find the missing side of a right triangle? Pythagorean theorem. Across from the right angle, that's going to be your hypotenuse, that's your C. So y'all can solve that on your own. Okay, so we're almost done with our notes. I know it looks like we're only halfway done, but this set of notes is a lot shorter. Basically, if it's on the graph, you're going to do the same thing. You can do the same thing, but we have to use our on the graph formulas. So tape that little half sheet in your notes, and then grab flip your warm-up over. Yeah, flip your warm-up over to the circumcenter warm-up, and let me have you just follow these steps. Okay, pause the video if you need to. Unpause it when you're ready. And hopefully you had time to plot these points. And when you plot points, make sure you label them. So here's my triangle ABC. To find the circumcenter, remember we need to bisect at the side and then draw a 90-degree angle. So if I bisect the side on a graph, I have to use something called the midpoint formula. That's when you add the x's, divide by 2. So when I find the midpoint from A to B, if I add my x's, my x values are going to be 3 and 1. I'm going to add those, divide by 2, and my y values are going to be negative 2 and 4. So I would add those and divide by 2. So my midpoint from A to B is going to be 2, 1. And when you plot the midpoint, it better look like the midpoint. It better look like the point in the very middle. Okay, my slope of AB is rise over run, or y2 minus y1 over x2 minus x1. So my slope should be negative 3. To draw a circumcenter, we have to draw perpendicular bisectors, not just bisectors. So here's my bisector. I'm going to find the perpendicular slope. That's the opposite reciprocal. And I have a slope of 1/3. That's rise 1, run 3. So here is my perpendicular bisector for side AB. Now let's do the same thing for side BC. Find the midpoint first. That means I'm going to add the y values from B to C, divide by 2, add the y values from B to C, divide by 2. So you should get a midpoint of negative 1.5, comma 1.5. And again, when you plot it, it better be on your line. And then I'm going to draw a 90-degree angle, but the way to do that on a graph is you find the slope of the line, y2 minus y1 over x2 minus x1, and then you find the perpendicular slope, which is the opposite reciprocal. The opposite of a positive is a negative. The reciprocal of 1 is conveniently just 1. So rise a negative 1, run 1. Rise a negative 1, run 1. So here is my here's my perpendicular bisector of side BC. And yes, they intersect, but we need to intersect all 3 of our perpendicular bisectors because you might have messed up on one of them. So this is a good catch. So AC, the midpoint of AC, hopefully you already did this, is negative 0.5, comma negative 1.5. Good, it's on my line. Then I need to draw a perpendicular line because that's just the bisector. So I need to first find the slope, either rise over run or y2 minus y1 over x2 minus x1. And I get negative 1/7. So the perpendicular slope is the opposite reciprocal. So that's a positive, and then when I flip it, that's 7 over 1, which is just 7. So rise 7, run 1. Somewhere up there, I ran out of space. But that is my perpendicular bisector. So here is the intersection point. And I know it's not a nice, pretty number, so just get relatively close to it. The actual specific intersection point here is negative 2.5, comma 2.5 if you really cared. Okay, so to create a perpendicular bisector on a graph, you bisect it by using the midpoint formula, not by using a ruler. And then to find the perpendicular line, you have to have the opposite reciprocal slope. So first you actually have to find the original slope. Remember, the circumcenter is made of 3 perpendicular bisectors. So you need to do that for each side of your triangle. And then once you find that circumcenter, it's equidistant to the angles. So your homework tonight, I'm going to ask you to do this and then use the distance formula to prove that is equidistant to the angles. So tape your little warm-up on there, and then, tape your warm-up on there, and then go grab a warm-up. A homework. You also have your Khan Academy of the week. These are the Khan Academies of the week. You can do them during your study hall.